This comes out of section 7.4, Applications of Trig Derivatives. This question says, find the maximum perimeter of a right triangle with a hypotenuse of 20 centimeters. I'm going to do this two separate methods here. One will require trig functions and one won't. So we could have actually seen this question way back in chapter 4 when we did max min problems. We have ourselves a hypotenuse that's 20 centimeters long, and we have two sides, and I'll call them maybe x and y. And it is a right triangle, which makes my life a little easier in a whole bunch of different ways. And we're asked about the perimeter of this, so my objective is x plus y plus 20. That's what I'm going to try to maximize. But I do have a constraint, and the constraint is that this has to fit into this triangle. So x squared plus y squared equals 20 squared. So y equals 400 minus x squared all under the square root. So I could change my perimeter equation to be just in terms of one variable, x plus the square root of 400 minus x squared plus 20 is the perimeter of this right triangle. So now I can say, well, what's dp by dx? And so it's 1 plus a half times 400 minus x squared to the negative a half times negative 2x, and then the derivative of 20 is 0. It's a maximum problem, so I want my derivative to equal 0. So I try to solve this. Where does 0 equal 1 minus x over the square root of 400 minus x squared? I just did a tiny bit of simplifying there to say 2 over 2 cancels out and the negative can come up front. So really I'm solving where does x over the square root of 400 minus x squared equal 1. You can cross multiply or you can square everything right now. At some point we're going to need to get rid of that square root. So I can get to the next stage, which says x squared over 400 minus x squared equals 1. Squared everything. X squared equals 400 minus x squared. I multiply the denominator to the other side. So 2x squared equals 400. X squared equals 200, which means x equals the square root of 200. Now, you could say that that's 10 root 2. That would be good. If you go back up above to this, we're asked what's the maximum perimeter. The perimeter is actually equal to x plus y plus 20, pardon me, or x plus the square root of 400 minus x squared plus 20. And what you actually find about this triangle is it ends up being isosceles, in that these two sides end up being, this one's 10 root 2, and this one is also 10 root 2, and plus 20. So the maximum perimeter you could get out of this is 20 root 2 plus 20. We could come up with a decimal answer, but this is better. So there's solution A, and that solution, took us a few minutes to get done. 3 minutes on my recording so far. And, we could have done it in chapter 4. Now, if I set this up in a very similar way, I've got my 20, my right angle, my x, and my y. And if I introduce also the fact that I know that this is an angle, and I say, well, cosine of x would be, cosine of theta, would be x over 20, which means x equals 20 cos theta. Sine of theta would be y over 20, so y equals 20 sine theta. We know that the perimeter was x plus y plus 20 from way up above, or even just from right here, and so perimeter could also be said as 20 cos theta plus 20 sine theta plus 20. I have now what I usually want to have in these situations, which is an equation for my objective in terms of one variable. I do dp by d theta, and I get negative 20 sine theta plus 20 cos theta plus 0, and I want to make that equal to 0. If you do that, you get 20 cos theta equals 20 sine theta, or rearrange, divide by 20 cos theta on both sides, you get 10 theta equals 1. Now, you might know this one off by heart depending on how well you did with your Math 30 trig, but there is an angle that is going to fit in here that gives me with tan, theta equal 1, and that is 45 degrees, or pi over 4 radians. There are others that are bigger, but obviously they wouldn't fit into this little right triangle. So if that's the case, I can go back here and say, well, my perimeter equals 20 times cos of 45 degrees plus 20 times sine of 45 degrees plus 20. Now, these are 20 times root 2 over 2 plus 20 root 2 over 2 plus 20. And it ends up giving you, not surprisingly, I hope, the exact same answer as what we had up above. 20 root 2 plus 20 centimeters is the biggest perimeter you can make out of a triangle that has hypotenuse. Right triangle has hypotenuse of 20. The second method I showed you there had quite a bit easier derivative to take, I think. I mean, less chain rule, no chain rule, and even the solving. Some people with the square roots and everything up above get bogged down and get stuck with the solving there. So either way, if you're able to get to the answer, you're able to get the answer, you got it right, you're good. Max min problems with trig.